The topic of this video is visualization. We are going to work with the LiDAR points. At the moment, the LiDAR points are drawn not in the correct frame of reference. This is the rear wheel of the go-kart, and the LiDAR points are drawn as if the LiDAR was at the origin here. So we have to move the origin of the LiDAR somewhere here, so that the LiDAR points are drawn accurately with respect to the true origin. I'm going to work in an existing, I'm going to branch off from an existing branch, VC001. I make sure I have the latest version, and I'm going to check out to a new branch with a similar name, but I'm gonna call it maybe M3, and I'm going to make it visible online. Okay, that's done. What we looked at before was the side LCM module, and it consists essentially of the blue LiDAR points. This is all the LiDAR points. It's called side LiDAR renderer. Then there is a side obstacle LiDAR renderer, which drew the red points. Then there is the side go-kart renderer, which at the moment just draws the rear wheel. So for simplicity, I'm going to comment this out, the obstacle LiDAR renderer, because then we have a better understanding of what is going on in the LiDAR renderer. So I press F3 to enter that class, and this part here draws the small green indicator of where the origin of the LiDAR is. So what I should do is, instead, I have to move the origin of everything that's going on in here, because everything that's going on in here is related to the LiDAR. So I want everything that happens here to be with respect to the origin of the LiDAR. There's already some comments here. So first, so the transformation from the origin to the coordinate of the LiDAR, to the center of the LiDAR, essentially consists of translation and a rotation of 0 degree. And we're going to translate along the x-axis first, and then the y-axis, which corresponds to the height in real space. So I essentially need to get two numbers right. The first one is the shift along the x-axis, and that one I can get from the VLP16 variable. I'm going to get the first coordinate, and then I can extract the double value from that. So that one takes care of the translation in the direction of the front of the go-kart. And next, I have to move the LiDAR up, and that is the variable indicated here. So this variable has a unit. I have to basically ask that this quantity is given in meter, as a double in meter. The way to do this is it's via the class called magnitude. I choose magnitude meter, apply to this value, and then again I'm going to extract this number as a double value. We could make this look slightly different and perhaps better if we, instead of creating this using this tensors vector, we can also use tensors off, and then we wouldn't need this double number extraction. We could just say these scalars here, and then, but then 0 doesn't work at this place. I have to put real scalar dot 0, and that should compile. So now there is no arrow. And that should already work. Let me run this from from the full capability offline processing program. So this is called run tab task queue. Note I press Ctrl Shift R for resource navigation. So I go to run tab task queue, and then I press Ctrl F11 to start it. And the modules that we need to start is the side view LiDAR. And you can see it's already shifted a bit up. So this is where the wheel was. That hasn't changed. The LiDAR green indicator is up. That's good. And now this is already pretty plausible, this visualization. Next I'm going to demonstrate how these quantities, where these values are, how we can change them live while the program is running, and then see the change in the visualization. So all the parameters are configured in this parameters module, and in this case it's in the sensors config. So we have the VLP 16. I can change that to a maybe ridiculous high number, 3 meters in the front. I press update, and then everything shifts a bit. I can make it even more obvious. I'll just move the LiDAR up by another meter, and then everything has shifted up here, and now the LiDAR is shifted in this position, which is wrong. So now instead of pressing save, I'll just close everything, and that resets to the old values. And finally, I'm going to draw maybe the front wheel. I hope maybe this can be done quickly. Let's see. So this is the side go-kart renderer. This code draws the rear tire, and my hope is that if we duplicate this code and make changes, it essentially should draw us the front tire. So let's see. Draw front tire. Tire radius front. And this is another example where the tire radius front is specified in as a quantity with unit. I'm going to demand that that is converted to meters. So if somebody specifies this radius in centimeters, that's fine. It's just converted to meter because the drawing happens in meters. So we need to translate. So the drawing essentially just draws a circle, which is specified centered around 0. So again, we'll just shift the coordinate system before we draw this circle. And this is a translation matrix again. So we have to, this translates up along y axis, and this is wrong because we need to translate all the way to the front front axis along the x axis. Let's see where this number is specified. We need to we go to chassis geometry, and then we see right up here is the distance from rear to front axle. This is what we need, and this is defined in meters. So we replace this 0 with chassis geometry global, and then axle rear to front. And this is again a quantity, so we'll make sure we get this in meter. Apply. And in this case, I'm just going to leave it like that. And so this should show us a second wheel, should show the second wheel, the front wheel, front tire. And I'm just going to run the side LCM module because I don't want to change the parameters. So let's see if the front wheel shows up. Yes, it shows up. So next we can, in the future, we can draw some more details and maybe the bumpers of the go-kart to get a better impression of where the what is the extent of the go-kart. So as usual, I will just I think I'm done with the topic list. I'll re-enable this code because this can be fixed later, and then I'm going to commit the changes. First I format everything, and perhaps there are some imports not used. Let's see here. So typically we can do that by pressing Ctrl-Shift-O, selecting the project and pressing Ctrl-Shift-O. Okay, and yeah, then that's all. And now the changes are online.